Okay, welcome to my YouTube channel, and right now we'll be talking about basics of classical computing or introduction to classical computing. So let's start. Okay, the book that I will be using for now is Quantum Computing for Babies by Chris Farley and Wurle. This is a very nice book, by the way. So first of all, let's talk about what is a bit. It says that the first term there is a bit of information. So what is a bit basically? So before moving on to this bit, let's talk about something that seems familiar, and it is electrical switch. So you might have seen in your home that we use switch sort of for everything. Like if you want to turn on a fan, you are using a switch. And what does this zero mean? Have you ever thought about it? This zero means that something is off, and this one means something is on. So, I always say that every country has its own languages. In the same way, every device has also its own language. And for switches, or I should say, yes, for switches, the language is binary. That is what I say, that they talk in binary language. Switches. Where in binary we mean 0 is off and 1 is on. So this is a language in which they speak about. So if we want to talk to computers, so in that way the computers basically talk in binary as well. Okay, 0 and 1, and this 0 and 1 is called a bit. It is just a terminology that you need to basically I guess you should just memorize it. That is a terminology in which 0 and 1 is bit, the language of computer. So it is also affect sort of that 8-bit makes a bytes. Okay. Upon moving forward, we will know why we are talking about bits and bytes. So here we go. Here we come. They say that there's an analogy that I always use. This is that if we talk about humans, don't mind my drawing, please. So, if it is a human, as blood flows in our body, okay. First of all, let me tell me, like for a human body, we know that cell is a basic unit of life, and in some way, just for analogy, I say that a bit is a basic unit of a computer. It's just like an analogy, so don't take it seriously. In the same way as blood flows in human body, it is bytes. I would say that many bytes make a data, and data lives in computer. Data is something that's living inside computer. Everything that you do in a computer, maybe it is a click, or it is you're scrolling over, or you're opening an application or something like that, you are editing something, this all these things you think basically lives as a data in the computer. It flows like as the blood flows in our body, that is how data flows in computer. Okay, let's just move on. We say that computers are useful, they solve problems. Okay, so I'll just give you an example that why do we need computers. I have a question that 2 plus 2. Okay, you know it, you know the answer, so you will say that's 4. But if I write a really large number like it's 1 8 7 6 9 divided by 4 4 7, then it's a tough problem. Okay, I know many people can do it by hand, but to reduce time, to increase efficiency, that is what we will doing it in a computer. Calculator is a form of computer, by the way. So we use computer to ease our life as a sort of comfort. So computers help us to solve complex problems in which we don't have to work a lot by our hand or something like that. So computers basically are used to solve problems, and how problems are solved by changing data. Okay, how that happens, like this example, let's take example. Like here you can see we have data that seems to look like this thing. Then it changes itself for some operation, that consider that it is 2 plus 2 happening inside the computer. So it's just an analogy, don't take it serious, okay? Then the data itself changes itself to solve this problem, and by the end of day we just assume that this byte means that 4. We started with 2, added 2 plus, and data somehow changes itself and we reach to 4. That is how computer is basically solving a problem by changing the data inside it. Okay, let's move on. It says that some problems are easy and some problems are hard. I gave you example before. This example. This one is this 2 plus 2 is an easy problem, while this one is 69 divided by 447. It's a difficult one. So some problems are easy, some are hard. Okay, we'll just leave our lecture for today for till now, because after that we have moved toward the quantum computing. And so if you have any sort of problem, which I believe it, you wouldn't, because it was easy, but if you have any problem, then you can write down in the comment section. I will make sure to answer. Okay, so bye for now.